In February 2017, in the freezing water off the west coast of Antarctica, a drill is lowered onto the floor of the sea. Picture the ship above it, a German icebreaker called the Polarstern, holding position in the Amundsen Sea, in the grey light that passes for daytime down there. The drill is a squat orange machine sitting on the seabed 1,000 meters below, chewing slowly into the mud in the dark, pulling up a core, a long, narrow cylinder of everything that has settled on that spot, layer by layer, for tens of millions of years. When they bring it up on deck and lay it out, the crew do what everyone does with a core. They look along it, grey, 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 and then one band of it is the wrong colour. That's all. That's the whole discovery, in the moment it happens. A stripe of sediment that simply doesn't match the layers above it. A different shade, in a tube of mud, at the bottom of the world. Somebody notices. Somebody says, "That's odd. Remember the layer that was the wrong colour? We come back to it at the very end of the night." They take it home to Germany and put it inside a CT scanner, the same kind of machine a hospital would use on a person. And the image that comes back is not sediment, it is roots. A dense, tangled network of them, spread through the entire layer, so perfectly preserved that the scientists can make out individual cell structures, cells, from something that grew. And around the roots, pollen, spores, dozens of species, including the pollen of flowering plants, the first ever found that close to the South Pole. 90 million years ago, on the spot where that ship was floating, there was a forest. Not scrub, not moss. A dense, swampy, temperate rainforest, with rivers running through it, in a place roughly 900 kilometres from the South Pole. A place that spent months of every year in total darkness and grew anyway. The annual average temperature was about 12 degrees Celsius, something like the rainforests on the west coast of New Zealand today. And all of that, the trees, the rivers, the ground it grew in, is still down there, under the ice, exactly where it stopped growing 90 million years ago, waiting in the dark. Because here is the thing about Antarctica that gets lost behind the postcards. It is not an empty white plain. It is a continent, the 5th largest on Earth, bigger than Europe, with mountains, valleys, canyons, lakes, rivers, volcanoes and coastlines. And every bit of that landscape is buried under a sheet of ice that is, in places, more than 4 kilometres thick. Not covered, buried, sealed, 34 million years ago, and never uncovered since. It is the only continent whose actual surface no human being has ever seen. So tonight, we go under the lid, slowly, layer by layer. What is actually down there beneath Antarctica's ice? What are the mountains no eye has ever looked at? What's living in the lakes that have been sealed in the dark since before our species existed? What did 3 dying men drag across the ice in 1912 rather than leave behind? And why did it turn out to matter so much? And what really happened to the continent that was buried alive? There is a mountain range under the ice the size of the European Alps. Nobody has ever seen a single peak of it. Hold that. There is a map, drawn in 1513 by an Ottoman admiral, that people will tell you shows Antarctica without its ice. We'll look at it tonight. The truth about that map is better, and stranger, than the rumour. You know the feeling of looking at a map and seeing a blank space where the detail should be. Most of the world's blank spaces were filled in centuries ago. Antarctica's blank space is not cartographic, it's physical. The ice is the blank. The land underneath is where the detail lives, and the detail has been waiting under 4 kilometres of solid white for 34 million years. There are things down there that have not been disturbed since before our genus existed. Not our civilization, our genus. Before Homo habilis. Before any member of the Homo family was carrying a stone tool across a savanna. The ice was already old. The mountains under the ice were already sealed. The lakes were already dark. Before we go any further, Let me give you the scale of what you're about to descend through. Imagine 4 kilometers of ice above you. Not snow, ice, compressed by its own weight into something close to solid rock, blue at depth, full of ancient air trapped in bubbles the size of pinheads. The ice at the bottom of that column is under about 400 times atmospheric pressure. It is old in ways that are difficult to attach language to, and below it, still and dark and absolutely unknown to any human eye, is the continent. The instrument that pulled up that core was called MEBO, a robotic seafloor drill, operated from the polar stern, capable of drilling in water too deep and seafloor too remote for conventional methods. MEBO is a German abbreviation, Meeresbodenbohrgerät, seafloor drilling device. It sits on the seabed and drills autonomously, sending its cores back to the ship on a wire. The Polar Stern team was in the Amundsen Sea, near the Pine Island and Thwaites glaciers, studying the sediment record of past ice sheet behavior. They were not specifically looking for a fossil forest. They were reconstructing ice sheet history from the sediment. The forest found them. And there are lakes down there, sealed in the dark, that have not seen the sky since before anything human walked the earth. And in at least one of them, something is still alive. Let's go down. Before we go any further, you don't need to follow every word tonight. This is a slow descent through 4 kilometers of ice, and you can drift off at any depth. That's exactly right. The ice will still be there when you come back. The mountains won't move, and if you fall asleep somewhere between the surface and the forest floor, you've done the only thing this hour asks of you. This is for the ones who look at a map and wonder what's under the blank part. For the ones who find the familiar world slightly too small, who have always suspected that the planet still has rooms we haven't opened. For the quiet, patient, curious people who read footnotes and follow threads. The ones who know that the most astonishing stories are usually the ones with the best evidence. If any of that sounds like you, you're in exactly the right place. Settle in. Let your body be heavier than it was a moment ago. One question, before we go under. Where in the world are you tonight, and what hour is it where you are? I like knowing the geography of who I'm talking to at this hour. Someone is listening to this from a time zone I'd find surprising, at a latitude I haven't been to. Leave it below, I read every one, in the mornings, with something warm. And if this kind of night is what you come here for, a quiet tap-on like is enough. That's it. Everything else tonight is yours. Let me tell you what Antarctica actually is, before we talk about what's inside it. The continent covers about 14 million square kilometers. That number takes a moment to land. It means Antarctica is larger than Europe, larger than the United States and Mexico combined, larger than China. It is the 5th largest continent on Earth, and it sits at the bottom of the planet like a cap, centered almost exactly on the South Pole. If you traveled to the center of the ice sheet, you would be about as far from the open ocean as you can get on this planet's surface. The ice on top of it is not uniform. In the east, it is ancient and enormously thick. In places, the East Antarctic ice sheet runs to 4.5 kilometers deep. 4.5 kilometers of solid ice stacked up above the rock. For comparison, the highest building ever constructed by human hands is the Burj Khalifa in Dubai, at under a kilometer tall. The ice sheet over East Antarctica is more than 4 of those, sitting on a continent, in the dark, and it has been there for about 34 million years. In the west, the ice is different, younger, thinner, more dynamic, sitting over a landscape that in many places lies below sea level. West Antarctica is not a plateau, it is an archipelago, an island chain, with the ice sheet as an enormous frozen sea covering the gaps between the islands. Remove the ice from West Antarctica and you would have open water, a scattering of islands, and the transantarctic mountains rising from the sea like a spine. But the ice has not been removed. It was put there 34 million years ago, and it has stayed. The event that sealed the continent is one of the most significant climate transitions in the last 100 million years of Earth's history. It happened at the boundary between two geological epochs, called the Eocene and the Oligocene, a boundary marked, in rock cores around the world, by a sudden, sharp change. What happened was this. The levels of carbon dioxide in the atmosphere dropped significantly. The continents around Antarctica separated far enough to allow a continuous ocean current to flow around the entire continent. And that circumpolar current acted as a wall, a moat of cold water isolating Antarctica from the warmer seas to the north. The continent, already drifting toward the pole, was now thermally imprisoned. Temperatures fell. Snow that fell in summer stopped melting. Ice accumulated. The ice sheet was born. The forests died. The animals left or went extinct. And the lid came down on everything that had been living there. There is a mountain range down there the size of the Alps. Nobody has ever seen it. Hold that thought. We're going to spend a long time with it. Now, here is the question that makes Antarctic science so strange and so particular. How do you study a continent you cannot see? The rock is buried. The landscape is buried. You cannot simply look at it. You cannot walk across it and see what it looks like. Every description of the land surface of Antarctica is, in a precise technical sense, an inference, a deduction from signals that have passed through 4 kilometers of ice. The first method was seismic sounding. You set off an explosion or send a mechanical pulse into the ice, and you time how long the echo takes to return. The echo bounces off the rock beneath the ice, and from the time it takes to return, you can calculate the depth. This is how Antarctica's land surface was first mapped, by listening to it. The Soviets were particularly good at this in the 1950s, during the International Geophysical Year, when nations agreed to spend 18 months collectively studying the Earth's polar regions. Soviet expeditions crisscrossed the Antarctic interior with seismic equipment, setting off small charges and measuring the returns, gradually building a picture of a landscape nobody had ever looked at. Later came ice-penetrating radar, aircraft flying back and forth over the ice, with instruments that could send radar pulses through the ice and receive their reflections from the rock below. This method was faster and more detailed than seismic sounding, and over the decades, it built up the most comprehensive picture of the subglacial terrain. Then came satellite measurements, instruments in orbit measuring the precise shape of the ice surface. Because the ice surface is not flat, it follows the contours of the rock below it, and if you can measure the ice surface with enough precision, you can infer the shape of the land underneath. All three methods together have given us BedMap, a continuously updated model of the Antarctic land surface, constantly refined as more data arrives. The map is extraordinarily detailed. It shows mountain ranges, canyons, plains, troughs, valleys. It shows the Transantarctic Mountains, a range that actually does break the surface and can be seen, as a spine dividing the continent. It shows the deep basins of West Antarctica, lying below sea level. It shows, in the east, a high plateau, Dome A, the highest point of the ice sheet, sitting above a landscape that turns out to be anything but flat. And now let me give you the human thread that will run through the whole of tonight. Because facts without people are just facts. The heroic age of Antarctic exploration was a brief and brutal period in the early 20th century, roughly 1901 to 1917, when European nations sent expeditions south, competing to reach the pole and to map what had never been mapped. The most famous of these is Robert Falcon Scott's final expedition, which reached the South Pole in January 1912, only to discover that Roald Amundsen's Norwegian team had arrived 5 weeks before them. Scott and 4 companions turned around and began the 900-kilometer walk back to their base camp. They did not make it. They died in the tent in March 1912, caught by a blizzard when they were only 18 kilometers from a supply depot that might have saved them. Remember the Sledge. 3 men, dying, refusing to put something down. We'll come back to what was on it and what it proved later tonight. There is nothing under the ice that was ever hidden from us deliberately. There is no conspiracy here. The ice closed 34 million years before there was anyone to hide anything, and the scientists who study Antarctica publish everything they find. What lies beneath the ice has been inaccessible not because anyone kept it that way, but simply because 4 kilometers of ice is 4 kilometers of ice. The ice sheet on Antarctica holds about 26.5 million cubic kilometers of ice. If you were to melt it all, a process that would take far longer than human civilization has existed, global sea level would rise by roughly 58 meters. For tonight, the more interesting implication of that volume is what it represents as a time machine. Ice accumulates slowly. The East Antarctic ice sheet has been accumulating and compressing and flowing for about 34 million years, and the ice at its base is approximately that old. The sheet is not just a layer of frozen water, it is a physical record of time. The continent it covers has a history that most people do not know. In the Mesozoic era, the age of dinosaurs, Antarctica was not at the South Pole. It was warmer, wetter, and attached to the rest of Gondwana. The same continent that would eventually become the coldest, most isolated place on Earth was, 150 million years ago, part of the central landmass from which South America, Africa, India, Australia and New Zealand would separate and drift away. Antarctica was the last piece of Gondwana to become isolated. It drifted south slowly, losing its land connections one by one, until the final connection to South America was severed and the Drake Passage opened between them. The Drake Passage opening is the key event. It allowed the Antarctic Circumpolar Current to form, a continuous belt of ocean current flowing from west to east around the entire continent, driven by the prevailing westerly winds and unobstructed by any landmass. This current acts as the most effective thermal barrier on the planet. Warm water from the north cannot easily penetrate south past it. Combined with falling CO2 levels, this thermal isolation was enough to tip Antarctica's climate into a new regime. The snows that fell in summer stopped melting, ice began to accumulate, and the lid began to close. The International Geophysical Year of 1957 to 1958 was one of the most ambitious cooperative scientific projects ever undertaken. 67 nations agreed to coordinate scientific observations across the planet simultaneously, with particular emphasis on the polar regions. Antarctica saw an unprecedented concentration of scientific effort, research stations established, expeditions launched, instruments deployed. It was during this period that the first systematic seismic surveys of the Antarctic interior were carried out, the surveys that would eventually reveal the Gamburtsev Mountains. The Antarctic Treaty, signed in 1959, established Antarctica as a continent devoted to peaceful scientific research, with territorial claims frozen and military activity prohibited. It is, by most measures, one of the most successful international agreements in history, and it is the framework within which everything discovered about what lies under the ice has been discovered. You can think of the date 33.9 million years ago as the moment the jar closed. Everything living on the continent at that moment, the forests, the animals, the soil communities, the river systems, was caught, sealed, and the world above the seal continued changing through millions of years of evolution and climate shifts and the rise and fall of whole lineages of life, while below the seal, everything stayed exactly where it was the day the lid closed. The research stations of Antarctica are extraordinary things in themselves. There are approximately 70 permanent or semi-permanent stations operated by different countries, scattered across the continent and its islands. Some are on the coast, where conditions, while harsh, are manageable for year-round habitation. A few are on the interior plateau, where conditions are genuinely extreme, and winter over is only possible because the buildings are engineered to survive conditions that would kill an unprepared person within minutes. The most isolated of the interior stations, Vostok, Concordia, the Amundsen Scott South Pole Station, host small winter overcrews who remain through the Antarctic winter, months of total darkness and temperatures below -60 Celsius, conducting science and maintaining the stations in conditions that have more in common with a space mission than with any conventional human settlement. The people who winter over at these stations are among the most isolated human beings on Earth. They are doing it to study what lies under and around them. That commitment deserves acknowledgement. The ice itself has a physical reality that no photograph fully conveys. Near the surface, it is white, compressed snow, still carrying some of its original air. As you go deeper, the air bubbles are squeezed smaller, and the ice becomes clearer. At several hundred meters depth, it takes on a blue cast, a blue that exists because ice at depth absorbs the longer wavelengths of light and transmits the shorter ones. The blue of deep ice is the purest blue you will ever see. At greater depth still, at the base of the sheet where the ice is under 300 or 400 atmospheres, any remaining bubbles have dissolved entirely into the ice crystal structure. The ice at the base of the East Antarctic ice sheet is not simply frozen water, it is a different phase of water, maintained by conditions that don't exist anywhere else on Earth's surface. And yet, what is down there is extraordinary. Not because it's secret, because it was sealed. Sealed like a jar, sealed like a time capsule, sealed like a room that was locked at the exact moment of the last interesting thing that happened inside it. Let's find out what's in the room. In 1958, a team of Soviet scientists drove a convoy of tracked vehicles across the East Antarctic interior, a landscape so featureless that navigation depended largely on sun compasses and dead reckoning. They were part of the Third Soviet Antarctic Expedition, working during the International Geophysical Year, and their job was to take seismic measurements of the ice depth as they went. The work was hard and cold and routine. You set up the equipment, you set off a small explosive charge, you measure the time it takes the sound to return from the rock below, you write down the number, you move on. Except that one day, the echo came back wrong. Not wrong in a way that suggested equipment failure, wrong in what it described. The signal was bouncing off rock, yes, but the rock was much higher than it should have been. The Antarctic interior, in the geological theory of the time, should have been a stable continental shield, the sort of ancient, flat, worn-down platform found in the middle of most old continents. Ancient, undisturbed rock, ground flat by billions of years of erosion. The echo should have been coming from somewhere a kilometre or two below the ice surface, and the rock down there should have been smooth. Instead, the echo described a peak, and then another, and then a whole range of them, extending in every direction they surveyed. Sharp peaks, with valley shapes between them, topography like a mountain range the size of the European Alps, buried under up to 3 kilometers of ice, sitting in the middle of a continent where no mountain range should exist. Nobody had known it was there, nobody had ever seen it. When the Soviets named it, for the Russian geophysicist Grigory Gamburtsev, who had organized the seismic survey, they were naming something that no eye had ever looked at, the Gamburtsev subglacial mountains. That is the replay fact for tonight's 25th minute, and it is worth keeping with you. The Alps, buried under ice, hidden under the coldest interior on Earth, found only by bouncing sound off them. No human being has ever seen a single one of their peaks. The range runs for about 1,200 kilometers, roughly the length of Italy from the Alps to the toe of the boot. The summits reach around 3,000 meters above sea level, which puts them in the same class as the Austrian Alps. The valleys between the peaks have the sharp, carved quality of glacially sculpted terrain. In every respect, this is an alpine mountain range, except that it is invisible, buried under between 600 meters and 3 kilometers of ice, sitting beneath Dome A, the highest point of the East Antarctic ice sheet and one of the most inaccessible places on Earth. And for 50 years, nobody could explain what it was doing there. Here is the geological problem. The East Antarctic continent is very old, one of the oldest pieces of crust on Earth, with rocks more than 3 billion years old. Old cratons, the ancient cores of continents, are typically flat. They've had billions of years of erosion to wear them down, and they sit in stable positions where the tectonic forces that build mountains are no longer active. A sharp, alpine-scale mountain range in the middle of a stable ancient craton is, from a geological perspective, bizarre. It looks like something from the wrong kind of continent, in the wrong place, at the wrong time. The mystery sat there for 50 years, largely because getting to Dome A to study the Gamburtsevs is extraordinarily difficult. It is hundreds of kilometers from any Antarctic research station, at an altitude of more than 4,000 meters above sea level on the ice surface, in conditions that make fieldwork genuinely dangerous. Nobody had the resources or the logistics to mount a sustained scientific investigation, until 2007, when they did. The project was called AGAP, Antarctic's Gamburtsev Province. 7 nations contributed aircraft, equipment, people, and funding. The central instruments were 2 ski-equipped Twin Otter aircraft, small, robust propeller planes of the kind used throughout the polar regions, fitted with ice-penetrating radar, gravity meters, and magnetometers. For 2 complete Antarctic summer seasons, the aircraft flew back and forth across the Dome A region, in lines precisely spaced to build a detailed picture of the topography below. When the flying was finished, the team had covered about 120,000 kilometers, roughly 3 times the circumference of the Earth, over a survey area of around 182,000 square kilometers, all to look at a mountain range that nobody can see. That is the premium framing for tonight. 120,000 kilometers flown to X-ray mountains with radar, because there is no other way to look at them. It is one of the most elaborate acts of remote sensing in the history of science. The data that came back produced the most detailed map of the Gamburtsev range yet made. A picture of the full extent of the peaks and valleys, the drainage patterns, the ice thickness above the rock, the location of the ice sheet's origin on the Gamburtsev slopes, and the answer to the puzzle of why they're there was published in the journal Nature in 2011. The answer turns out to be one of the most beautiful things in this story. The Gamburtsevs are ancient. Their foundations are more than 1 billion years old. But they were revived. About 1 billion years ago, 2 ancient tectonic plates collided and pushed up a range, the original Gamburtsevs. Then the range eroded away over hundreds of millions of years, worn flat as old mountain ranges are. Then, about 300 million years ago, the supercontinent Gondwana began to break apart. The breakup sent a rift, a tear in the continental crust, across the region now covered by East Antarctica. Rifting stretches crust and makes it thinner, and when crust becomes thinner, the landscape rebounds upward. The old, flat, worn roots of the original Gamburtsevs were pushed up again, forming the sharp, alpine topography the Soviet expedition found in 1958. And then the ice came. Here is the beautiful part. The ice sheet that covers the Gamburtsevs began forming on the Gamburtsevs. The mountain range was the coldest place, the highest place, the place where snow first stopped melting year-round and began to accumulate. The East Antarctic ice sheet was born in the valleys of the Gamburtsev range. The ice grew outward from there, spreading across the continent over millions of years until it covered everything, and as it spread, it covered the mountains that had made it possible, sealing them under 3 kilometers of ice. The ice protected the mountains that made the ice. The range that initiated the glaciation was preserved from erosion by the very ice sheet its own elevation had helped create. That is why the Gamburtsevs still have sharp, alpine topography after all this time, because they have been sealed in ice for 34 million years, and erosion cannot reach them. A mountain range no one has seen, kept perfectly because it was buried before anything could wear it down. Let that sit for a moment. The Gamburtsevs are not the only buried mountains in Antarctica. They are simply the most surprising and most studied. The subglacial map shows mountain ranges throughout the continent, some of which are extensions of ranges that do break the surface. But the Gamburtsevs stand apart because of their location, deep in the interior of the stable East Antarctic craton, exactly where you would least expect to find mountains of any kind. The story of why they are sharp, why they have peaked, alpine topography, rather than the rounded, eroded profiles of old mountains, gets at something important about the relationship between ice and landscape. Erosion is patient. Given enough time, water, and flowing ice, mountains are worn down. The Scottish Highlands were once as tall as the Alps. What makes a mountain range sharp is not age, it is protection from erosion. The Gamburtsevs have had 34 million years of protection from the most effective erosion-preventing agent possible, a stable ice sheet that limits water flow and prevents the freeze-thaw cycles that break rock apart. The ice is, paradoxically, what has kept the mountains young. The AGAP project produced data that exceeded expectations. The resolution of the radar survey was high enough to image individual valley systems, to trace the drainage patterns of a landscape that hasn't had liquid water flowing through it in tens of millions of years. What those drainage patterns suggest is a mountain range that was, in its last exposed era, wet and dynamic. There were rivers in those valleys. The range was alive, in the geological sense, in the decades before the ice sheet expanded to cover it. And then one winter, the snow didn't fully melt. The following winter, unmelted snow from the first winter was joined by more. The ice began to grow outward from the mountains, flowing into the lowlands, covering the coasts, building the sheet that now covers the entire continent. These mountains have valleys between their peaks, U-shaped, glacially carved valleys. But there are no glaciers moving through them now. The shapes were carved long ago, before the full ice sheet covered everything. They have been perfectly preserved since. The colours are in the rock. The rock is in the dark. Nobody has ever seen those colours. And the ice protected the mountains that made the ice. This is the most elegant fact in tonight's story. Let me give you a clearer sense of the seismic survey method, because it is the foundation of everything we know about Antarctica's interior. You drive a series of explosive charges into the ice at intervals. You set them off. The explosion sends a pulse of energy downward through the ice, through the rock below, reflecting off different surfaces and returning to sensors laid out on the ice surface. The time it takes to return from each surface gives you the depth of that surface. Do this hundreds of times across an area, and you build up a three-dimensional picture of the rock below. It is like using sound to see, applied to geological survey on a continental scale. The Soviet expeditions of the late 1950s were doing this work in some of the most extreme conditions on Earth, using equipment that was heavy and temperamental, designed for climates far less severe than the Antarctic interior. They pulled the equipment on sledges. They set off charges in holes drilled into the ice. They read the instruments in temperatures below -40. They wrote the numbers down, and from those numbers, a mountain range emerged. I want to pause on the elegance of this for a moment. The Gamburtsev Mountains were discovered by people who never saw them, using instruments that sent sound into the ground, in one of the most inhospitable places on Earth, during a period of cooperative scientific effort between nations that were simultaneously engaged in the most intense geopolitical competition in history. The International Geophysical Year, within which the Soviet Antarctic expeditions operated, was itself a product of the Cold War, a space in which American and Soviet scientists agreed to share data on the Earth's polar regions, even as their governments were racing to put satellites in orbit. The Gamburtsevs were found inside a brief window of international goodwill carved out of the middle of the 20th century's most dangerous decade. The name Gamburtsev, from Grigory A. Gamburtsev, a Soviet geophysicist who organized the seismic survey program and died in 1955, 2 years before his equipment found the mountains that would bear his name, carries something of that history. He organized the survey. He never knew what it found. The mountains were named for him in recognition of the work he had designed. There is something appropriate about a mountain range no one has seen being named for a person who died before it was found. Named for the method, not the discovery. The valley floors of the Gamburtsevs, if you could somehow be standing in one, would feel ancient in a way that no valley you have ever stood in feels ancient. Every valley accessible to humans has been exposed to the atmosphere for as long as the valley has existed. Wind has moved across it. Rain has fallen into it. Organisms have colonized it, died, left their traces, been succeeded by other organisms. The valley has had a history. The Gamburtsev valleys have had no history since the ice closed over them. They are 34 million years old, in the same condition they were on the day the ice sealed them. No wind, no rain, no organisms, no succession, just the shape of the rock, and the cold, and the dark, and the absolute patience of geological time. The question that the Gamburtsev data has not yet fully answered is where the ice sheet will form again, not in Antarctica, but on other worlds. The process by which mountains at altitude initiate glaciation, then get sealed by the ice they helped create, is not unique to Earth. Any rocky planet at the right distance from its sun, with the right mix of volatiles and the right topography, might go through something similar. The Gamburtsevs are the case study. The mechanism is preserved, along with the mountains, under the ice. Hold a number 400 lakes. We'll get to those later, much later, when we go all the way under. Right now, let's go deeper, in a different direction. The mountains are one kind of secret. The ground they stand on is another. Bridge, a mountain range no one has seen, kept alive under the ice. But the mountains are only one layer of what's down there. Before the ice came, this continent had a whole life, and the evidence of that life is preserved in the rock and in a tube of mud on a shelf in Germany. Let's go back 34 million years further. Let's talk about what Antarctica used to be. To understand what lies under the ice, you have to understand what was there before the ice arrived. Antarctica was not always at the South Pole. For most of geological time, it was part of a larger landmass, the supercontinent Gondwana, which encompassed what is now Antarctica, South America, Africa, India, Australia, and New Zealand, all joined together in one enormous piece. Gondwana began breaking apart about 180 million years ago as the pieces separated and drifted, driven by the slow churning of the mantle beneath them. Antarctica drifted south, but it drifted slowly, and for much of its southward journey, it was warm enough to support forests. The fossil record from Antarctic rocks is one of the most quietly extraordinary archives in science. If you visit the right outcrops in the Transantarctic Mountains, the ranges that still break the ice surface and can actually be reached by field parties, you can find seams of coal, which is compressed ancient plant matter, deposited when forests covered the region. You can find the leaf impressions of ancient trees pressed into mudstone. You can find the bones of dinosaurs, Antarctic dinosaurs, which roamed a forested continent before the ice arrived. You can find the bones of early marsupial lineage mammals, dating from the period when Antarctica was still attached to South America, and the mammals of the two continents could walk from one to the other. All of this was known before 2017, but the 2020 paper from the Polar Stern drilling changed the picture in a specific and rather astonishing way. Most of what we knew about Antarctic forests was old, from the Cretaceous period or earlier, from times when the continent was still far enough north for warmth to be less surprising. The 2020 core was different. It dated to roughly 90 million years ago. Still the Cretaceous, yes, but from a time when Antarctica was at roughly the latitude it occupies today. The site of the drilling was about 900 kilometers from the position of the South Pole at that time. And at that latitude, in that era, there was a dense, swampy, warm, temperate rainforest. Here is the detail that makes this discovery so specific. The scientists did not begin with a theory and look for evidence. They began with an observation. When the core came up on deck, one layer simply looked different. The lead scientist, Johan Klages of the Alfred Wegener Institute, has described the moment of realization. The color was the first signal. Everything else, the CT scanning, the identification of the roots, the extraction and analysis of the pollen, followed from someone noticing that one band of grey mud was not quite grey enough. That is the premium framing for tonight's first segment. The greatest Antarctic paleoclimate discovery in a generation came down to colour. The giveaway was that one layer of a mud core simply looked different from the layers above it. The CT images were remarkable. The roots were so well preserved that the cell structure was visible, not just the gross shape of the root system, but the cells that made up the root tissue, cells from a plant that died 90 million years ago, preserved in cold mud at the bottom of the Amundsen Sea. The pollen was equally specific. Dozens of species identified from the spore and pollen types present, including the flowering plant pollen that represented the southernmost find of its type ever made. The reconstruction of the climate at the site is what most people find hardest to visualize. A mean annual temperature of roughly 12 degrees Celsius, summer temperatures reaching perhaps 19 degrees, a forest dense enough to build a root network complex enough to preserve in this form. And then the complication. The site spent 3 to 4 months of every year in total polar darkness, as the South Pole does today. The forest grew through months-long winters of complete dark, as well as through the summer light. It is, in some respects, more remarkable than a tropical rainforest, because a tropical rainforest never has to manage months without any sun at all. The closest modern analogue, according to the researchers, is the temperate rainforests of New Zealand's South Island. Cool, dense, wet, with southern beech and tree ferns dominating the canopy. All of that is under the ice. The actual ground that forest grew in, the soil horizon, the root zone, the sediment layer where the pollen settled, is still there, at the bottom of the Amundsen Sea, covered by younger sediments and then by the seabed, the fossil ground of the rainforest, unchanged for 90 million years. And then the lid came down. 34 million years ago, the Eocene-Oligocene transition reset the Antarctic climate in a matter of tens of thousands of years, which is an eye blink in geological time. The exact combination of causes is still debated, but 2 factors are well established. First, atmospheric carbon dioxide levels fell significantly, the greenhouse effect weakened, and the planet cooled. Second, the last land connections between Antarctica and the other continents were severed. South America and Antarctica had been linked by a land bridge, and when it broke, the Drake Passage opened between them. Antarctica was now surrounded by open ocean on all sides, and within that ocean, a current began to develop, the Antarctic Circumpolar Current, which flows continuously around the continent and acts as a thermal barrier. Warm water from lower latitudes cannot easily penetrate south of the current. Antarctica was isolated thermally as well as geographically. The forests died back, ice accumulated, the ice sheet grew, and within a geologically brief period, a continent that had supported rainforests was sealed under kilometres of ice from which it has never emerged. Now, 3 lenses on what this means. The geological reading is the simplest and the most secure. Antarctica is a preserved landscape. The ice is not a hiding place. It is a preserving medium. What lies under the ice is not hidden in any meaningful sense. It is simply very cold and very well insulated. The Gambutsev Mountains have maintained their sharp alpine topography for 34 million years, precisely because the ice has prevented the erosion that would otherwise have worn them smooth. The fossil ground of the rainforest is still there because nothing has disturbed it. The continent is a time capsule in the most literal sense, not sealed deliberately, but sealed by physical process, and the seal has held. The second reading is older and more resonant, and I want to give it its fair hearing before I tell you what I think of it. There is a tradition in very ancient literature, including the Enochic texts we've explored in earlier nights on this channel, of a sealed place at the ends of the earth, a region beyond the known world, closed off, where something is kept that cannot be reached. The image of a sealed southern continent, hidden under ice since before human memory, resonates with that tradition in ways that feel almost deliberate. I want to be careful here. The ice closed 34 million years before there was anyone to write anything down, and this is resonance, not evidence. The connection is poetic, but it is worth naming because the traditions that imagine a sealed place at the ends of the earth were imagining something real. They simply did not know what it was. The third reading is the one that sells books and makes documentary thumbnails. The idea that something human is under the ice. A civilization, hidden ruins, a history we've been denied. I want to give this a fair answer rather than a dismissive one. The date does the work politely. 34 million years. There was no human, no primate, no mammal resembling anything we'd recognize. 34 million years ago. The ice sealed a world of forests and rivers and insects and early mammals. Not a world of cities. Whatever is under the ice was not built. But here is the thing about the lost civilization framing. It undersells the real discovery. What lies under the ice is not a lost civilization. It is something rarer, an entire natural world stopped mid-sentence and kept. A mountain range, a fossil forest floor, the geology of a continent in its last green moment. That is not less interesting than lost ruins. It is, arguably, more interesting, and it is true. Let me give you more of the pre-glacial world, because it is genuinely extraordinary. In the early Eocene, roughly 50 to 55 million years ago, average temperatures in parts of Antarctica were around 12 to 15 degrees Celsius, warmer than London's average today. The fossil record includes plants that today live only in temperate and subtropical zones, species related to modern Australian and South American flora, which makes sense given that Gondwana was still breaking apart and the land connections were still open migration routes. The marsupial mammal fauna of Antarctica in this period is particularly striking. Antarctica served as a corridor, the pathway through which the marsupial mammals that would eventually populate Australia made their way from North America through South America, across the Antarctic connection and into Australia. Without the Antarctic land bridge, the extraordinary marsupial diversity of Australia might never have existed. The kangaroos, the wombats, the koalas, their ancestors crossed Antarctica. The continent is woven into the evolutionary history of life on Earth in ways most people have never heard. The pollen record from the 2020 core is a kind of species inventory of the last forest. Dozens of types of pollen and spores identified, representing different plant groups. The root network preserved in the CT scans tells you that this was not thin, scrubby vegetation struggling at a challenging latitude. The roots are intertwined the way established forest root systems intertwine, a web of connections that in modern forests runs continuously across hectares, the trees sharing nutrients and chemical signals through mycorrhizal networks. This was a healthy forest, at home in its environment, doing what forests do. And then it was shut in. Not burned, not drowned, not eroded. Simply shut in by a climate that changed faster than the trees could adapt. The question of what Antarctica looked like in its last green era is one that draws together evidence from many sources, and the picture they build is specific enough to deserve dwelling on. The coal seams visible in the Transantarctic Mountains, the same coal seams from which Scott's party took their Glossopteris specimens, are the compressed remains of ancient forests. For coal to form in the Transantarctic Mountains, there had to be dense forests covering enough area for a significant depth of plant matter to accumulate and be buried. The coal seams are not thin, they are seams, continuous deposits visible in cliffs, meters thick in places. The petrified wood, found in Antarctic outcrops, tells a similar story in greater detail. Petrification preserves the cellular structure of wood. You can identify the type of tree from the pattern of the cells. The petrified logs found in Antarctic exposures show wood anatomy consistent with conifer-type trees, the dominant trees of the Mesozoic high-latitude forests. The growth rings in the petrified wood carry a remarkable signal. The trees grew in rings that were not uniform. Some rings are very wide, a good year, warm and wet. Some are narrow, a difficult year. And some of the wider rings have a distinctive structure indicating a burst of growth, followed by quiescence, followed by another burst. This is the pattern of a tree that lives through months of polar darkness and then responds to the return of the sun with a surge of growth. These were trees that managed the polar night. The 2020 core adds something no previous evidence had quite captured: the flowering plants. Finding their pollen in a 90-million-year-old Antarctic core means they reached the polar regions earlier than previously documented. The continent was not on the edge of the habitable world, it was fully within it. And the rainforest that grew at 900 kilometers from the South Pole is the strongest evidence yet for what Antarctic scientists call the warm polar climate problem. The observation that polar temperatures in the Cretaceous were much warmer than current climate models predict. The Antarctica forest is not just evidence for what was there, it is a question about the climate system that we have not yet fully answered. The transition from the green Antarctica to the frozen one was not, from the perspective of the organisms living through it, a quick catastrophe. It unfolded over thousands of years, which is fast by geological standards, but is still thousands of years of gradual change in which organisms were adapting, moving, dying at the slow pace of climate-driven extinction. The forests retreated southward, or to higher altitudes, or into warmer coastal pockets, before they were finally overtaken. There would have been, for a very long time, a patchy Antarctica, forests in the warmer places, open tundra in the colder ones, ice beginning to accumulate in the highest terrain, but not yet covering everything. The last Antarctic forest, whatever it was, wherever it grew, was surrounded on all sides by something that was becoming winter, and then by winter that was not ending, and then by winter that was becoming permanent. The moment the last tree died is not recorded anywhere. It is somewhere in the sediment, in a transition from organic-bearing layers to layers that are purely mineral, a boundary that represents, at the most specific possible level, the end of life on the Antarctic surface. Somewhere in a core, the trace of the last tree. Nobody has yet found exactly where that line is. It is in the archive, waiting, and there is a map drawn in 1513 by an Ottoman admiral that people will tell you shows Antarctica without its ice. We'll look at it tonight, later, when we get to that layer. The truth about that map is better than the rumour. Bridge, no city. What's under the ice is far harder to imagine, and much bigger. A whole geography of a country nobody has ever stood on. Let's go and walk it. The subglacial map of Antarctica, the bedmap model, constantly updated as new surveys add detail, shows a landscape unlike any other on Earth. Not because it is alien, but because it is a fully formed continental geography that has been hidden, and when you see it revealed, it looks like something between a familiar country and a dream of one. The Transantarctic Mountains form the continent's spine, a range that actually does break the ice surface and can be seen. They run for about 3,500 kilometres, dividing the continent into two distinct halves. To the east of the Transantarctics lies the East Antarctic Craton, ancient, stable, high, cold. To the west lies the West Antarctic Rift System, younger, more dynamic, structurally more complex, and in many places lying well below sea level. That last detail is important. The bedrock of West Antarctica is, in places, more than 2 kilometres below sea level. If the ice were removed from West Antarctica, the sea would rush in. What you would have is not a western continent but a western archipelago, a scattering of islands rising above the water, with open ocean in the low-lying basins between them. West Antarctica is currently a sea disguised as a land, held in place by the weight of the ice above it. Among the features visible in the subglacial map are canyons that make the Grand Canyon look modest. There are buried channels longer than 400 kilometres, carved by ancient rivers when Antarctica was warm and wet, now filled with ice. There are buried valleys running to depths that no surface terrain in the world can match. The deepest of these is the Denman Trench. Here is the replay fact for this part of the night, seeded now, and to be paid in full later. The deepest known point of land on Earth is not the Mariana Trench. That is the deepest point in the ocean. The deepest point of land, the deepest continental surface, is in Antarctica. The Denman Trench in East Antarctica reaches more than 3,500 meters below sea level. It is a canyon, a genuine land surface, deeper than any continental point anyone has ever measured, and it is filled with ice. It is invisible. It is, in every respect, the deepest room in the world, and no one has ever been inside it. Let that number settle. 3,500 meters below sea level, filled with ice, at the bottom of a continent, in the dark. The ice itself is not uniform in character. The deepest Antarctic ice, the ice near the bedrock, at the bottom of a sheet 4 kilometers thick, is old beyond easy imagining. Near the surface, the ice is a few thousand years old. The further down you go, the older it gets, because each layer was laid down when the snow that fell on it originally fell. At the base of the East Antarctic ice sheet, you are in ice that fell as snow in an era before modern humans, before anatomically modern Homo sapiens, before any of our ancestors had done anything that has been written down. Ice that old is dark, not black, but a very deep blue, compressed by the weight of everything above it. Its air bubbles squeeze to near invisibility. It creaks. It is under enormous pressure. It is, in its way, a living thing, moving, flowing, responding to the forces upon it. The air above the East Antarctic Plateau is the coldest air on Earth. The coldest temperature ever recorded on the surface of the planet, minus 89.2 degrees Celsius, was measured at the Soviet Vostok station in 1983. The coldest estimated temperatures in the atmosphere have been even lower. In winter, the katabatic winds pour off the high plateau and down to the coast, reaching hurricane force. Nothing lives on the interior ice. Nothing visits. The interior of East Antarctica in winter is, in a genuine sense, the most lifeless place on the surface of the Earth. But let's go down. Let's go under the surface and further back than the ice, into the rock that the ice has been covering and preserving, because the rock remembers everything. In 1910, Robert Falcon Scott led his second Antarctic expedition from Cardiff, aboard a ship called Terra Nova. The expedition had two stated purposes: to reach the South Pole and to conduct science. Scott was a Royal Navy officer, not an academic, but he took science seriously. The Terra Nova expedition carried a team of geologists, meteorologists, biologists and physicists, and Scott intended that they should earn their passage south. By January 1912, Scott and 4 companions, Wilson, Bowers, Oates and Evans, had reached the South Pole, arriving on the 17th of January, only to find Amundsen's Norwegian flag already planted there. They turned around. They began the 900-kilometre march back to base camp. They were already weakened, frostbitten, moving too slowly. Evans died first, in February, probably from a head injury and the cumulative effects of exhaustion. Oates walked out of the tent in early March, on his 32nd birthday, into a blizzard, saying he was going outside and might be some time. He did not return. Scott, Wilson and Bowers reached a point about 18 kilometres from a supply depot called 1 Ton Camp, where they had food and fuel. A blizzard pinned them in their tent. They were too weak to wait it out. They were found in November 1912, when a search party reached the tent. And here is the thing. Here is the thing that every account of Scott's death mentions, and almost no account stops long enough with. Beside the bodies, on the sledge that the men had dragged across the polar plateau for 900 kilometres, there were 35 pounds of geological samples, 16 kilograms of rock. Nobody had told them to keep it. No one was forcing them to pull it. At any point in the march, they could have lightened the sledge. They were dying, and they knew it, and 16 kilograms of rock is 16 kilograms that might have been food or fuel or simply not having to pull quite so hard. And they kept it anyway. Here is the replay fact for tonight's 55th minute. Scott's polar party hauled 16 kilograms of rock on their sledge until they died. And inside that rock were leaves. Specifically, they were the fossilized remains of a plant called Glossopteris, a fern-like tree that grew across the southern supercontinent of Gondwana during the Permian period, roughly 250 to 300 million years ago. The leaves of Glossopteris are a particular shape, and they had been found on every other continent that had been part of Gondwana: South America, Africa, India, Australia, but not Antarctica, which had never been properly surveyed. The specimens Scott's party collected were among the first Glossopteris fossils ever found in Antarctica, and they proved 2 things: that Antarctica had once been forested, and that it had once been physically joined to the other southern continents. They were evidence for the theory of continental drift, evidence that, in 1912, the scientific establishment had not yet accepted. The geologist on Scott's expedition, Edward Wilson, knew what the leaves meant. He knew they mattered. He died carrying them. If you're still awake at this point in the night, and I hope you are, though I understand if the ice has done its work, I have a question for you. What's the one thing you'd refuse to leave behind, if leaving meant you might survive? Tell me below. Someone reading at this hour will have an answer that surprises them. The Glossopteris specimens are now held at the Natural History Museum in London. They are one of the most historically significant geological samples in existence. They proved Gondwana. They proved Antarctic forests. And they were kept because 3 exhausted, dying men decided that what they had found mattered more than 16 kilograms of survival weight. The rock remembers the forests. The men carried the memory of the forests back from the ice. And the forest floor is still down there, 90 million years of it, waiting in the dark. Now let's open the map. In 1513, an Ottoman admiral and cartographer named Piri Reis completed a world map. It is a remarkable document, a large chart drawn on gazelle skin showing the Atlantic Ocean with the coastlines of Europe, Africa, and the Americas on either side. For a European at the time, this was cutting-edge cartography. For Piri Reis, it was a compilation. He explicitly noted in the marginalia of the map that he had drawn on older sources, including charts that had come to him through various channels, some of which were pre-Columbus. In 1929, the map was rediscovered in the Topkapi Palace in Istanbul and attracted scholarly attention. In 1960, it attracted a different kind of attention. Charles Hapgood, an American academic, not a cartographer, not a geologist, published a book arguing that the southern coastline of the Piri Reis map depicted Antarctica without its ice cover. He argued that the general shape of the southern land mass on the map corresponded to the shape of Antarctica's bedrock, as determined by modern seismic surveys, and that therefore the map was based on a source that predated the glaciation, a source from a time when Antarctica was ice-free and presumably had been surveyed by some unknown civilization capable of making accurate maps of a continent 34 million years before anyone had the concept of a continent. The Hapgood interpretation is not accepted by mainstream cartographic scholarship. The reasons are specific and worth knowing. The southern landmass on the Piri Reis map is, in the scholarly consensus, a representation of the South American coast, extended southward and distorted. The kind of distortion that happens when you try to fit a spherical world onto a flat surface using the projection methods available in the 16th century. The shape of the southern landmass does not, when examined carefully by cartographers, actually match the shape of Antarctica's bedrock, and the claim that it shows ice-free Antarctica requires a chain of assumptions that each individually strain plausibility and collectively collapse under any serious examination. That is the honest answer to the Piri Reis claim. I want to be specific about it. The claim doesn't work, and the reasons it doesn't work are interesting and worth knowing, not dismissive trivia. But here is the genuinely astonishing thing about Renaissance cartography, that almost no retelling of the Piri Reis story dwells on long enough. The modern map of Antarctica's land surface, bed map, was drawn without anyone seeing it either. The map of what lies under the ice was made by aircraft flying radar surveys, by seismic soundings bouncing signals off rock, by satellites measuring the precise shape of the ice surface. The scientists who built BedMap have never seen the mountains in the Gamburtsev Range, never looked directly at the Denman Trench, never viewed the subglacial canyons of East Antarctica. They have inferred everything from signals. Piri Reis drew a map of a southern land using older sources whose nature we do not fully understand, producing a chart that shows something, some configuration of southern coastline, that may or may not correspond to anything specific. We drew a map of Antarctica's bedrock using radar and gravity data and seismic echoes, producing a chart that shows with extraordinary precision the shape of a land surface that no one has ever looked at. Two maps, both made blind, 5 centuries apart. One is the subject of conspiracy theories, the other is the map everyone uses, and they have more in common, epistemologically, than either camp usually admits. Now the volcanoes. In 2017, the same year the Polarstern was pulling up its mud core from the Amundsen Sea, a survey team published a paper in the Geological Society Special Publications reporting the results of a comprehensive analysis of the subglacial topography of West Antarctica. They had been looking for signs of volcanic activity beneath the ice. What they found was not nothing. The survey identified 91 previously unknown volcanic peaks beneath the West Antarctic ice sheet. 91. Most are tall enough that their summits approach the base of the ice sheet above them. Some may have had eruptions in geologically recent history. Geologically recent meaning within the last 50,000 years or so. The largest of the identified peaks reaches close to 4,000 meters above the bedrock on which it stands. If any of these volcanoes have been active in recent millennia, the implications are significant. A volcano erupting under kilometers of ice does not produce a conventional eruption. It produces meltwater. Heat from below the ice meets the ice from above, and the result is liquid water at the base of the ice sheet in a confined space. The water would be trapped by the weight of the ice, flowing along the base of the sheet toward lower ground. This is one of the mechanisms that has been proposed for the formation of Antarctica's subglacial lakes. Volcanic heat and geothermal warmth from below, keeping basal water in its liquid state, even under the enormous pressures of the ice above. And then there is Erebus. Mount Erebus is the southernmost active volcano on Earth. It stands on Ross Island, at the edge of the Ross Ice Shelf, at an elevation of about 3,700 meters. Its summit hosts a persistent lava lake, a bowl of molten rock that has been continuously active in the geological record for as long as anyone has monitored it. Erebus steams and burbles and occasionally tosses out lava bombs. It is the most studied active volcano in Antarctica and one of the most studied anywhere, and it has been doing this while the rest of the continent sleeps under its ice. The West Antarctic basin deserves more attention than it typically gets, because it is genuinely one of the stranger places on the subglacial map. To understand it, you need to think about what it means for land to be below sea level. In the Byrd subglacial basin, the bedrock is more than 2 kilometers below sea level, not a coastal shelf, but the interior of a landmass. The reason is the weight of the ice above it. The ice sheet is so massive that it has literally pushed the continent down into the mantle, a process called isostatic depression. West Antarctica is currently a sea disguised as a land, held in place by the weight of the ice above it. If the ice were removed, the sea would rush in, and what you would see from the air would look something like the Norwegian coast. Fjords, islands rising from cold water, mountains as the far horizon. A Norway, hidden under the world's largest ice sheet. Now let me stay with Scott for a moment longer, because the full picture of what his party found is worth having. Edward Wilson, the expedition's physician, one of the 3 who died in the tent, had been collecting rocks systematically throughout the journey. The Glossopteris specimens were collected from coal seams in the Beardmore Glacier region. Glossopteris is a distinctive genus. Its leaves have a particular shape that makes them recognizable even when compressed and fossilized. The genus lived from the Permian through the Triassic and was a characteristic component of the Gondwana flora, found in fossil form on every continent that was once part of Gondwana. In 1912, the significance was not yet fully established. Alfred Wegener had proposed continental drift that very year, and the scientific mainstream had not yet accepted it. The Glossopteris specimens from Scott's Sledge were, in due course, one of the pieces of evidence used to build the case for plate tectonics. Wilson chose to keep them when he was dying because he had committed himself to bringing back what he found. Let me stay with the maps for a longer moment, because the Piri Reis map has a history more interesting than either the conspiracy version or the dismissive version conveys. Piri Reis was a remarkable figure, an Ottoman naval admiral born around 1470, with access to the most current geographical knowledge of his time. He was explicit about his method. In the map's inscriptions, he described using 20 source charts, including charts from Columbus. The southern landmass on the 1513 map fits the tradition of the Terra Australis Incognita, the unknown southern land proposed by ancient Greek thinkers as a necessary counterweight to the known northern land masses. The modern bedmap model is a different kind of epistemic achievement. The integration of data from thousands of airborne surveys, ground measurements, and satellite observations, extraordinarily accurate in surveyed areas, carrying explicit uncertainty estimates where it is not. Both maps were made without anyone seeing the thing they describe. Different methods, different accuracies, the same fundamental situation, drawing a map of an unseen world. The 2017 survey that identified 91 previously unknown volcanic peaks beneath the West Antarctic ice sheet was not looking for surprises. The surprise was in the number. 91 is a major volcanic field, comparable in number of individual centers to some of the most volcanically active regions on Earth. with the unique distinction of being buried under the world's largest ice sheet. If any of these volcanoes have erupted in the last 50,000 years, the meltwater generated would have affected the hydrology of the entire West Antarctic basal system, filling and connecting lakes, driving flows through the subglacial drainage network, potentially influencing the flow of ice toward the coast. The Transantarctic Mountains themselves deserve a moment, because they are one of the most remarkable mountain ranges on Earth, and they are one of the few parts of the subglacial world that you can actually see. The Transantarctics run for about 3,500 kilometers, roughly the length of the continental United States from east to west. They reach heights of more than 4,000 meters. They rise from the East Antarctic Plateau on one side and drop steeply to the Ross Ice Shelf on the other, forming a wall that separates the two halves of the continent. The dry valleys, a region where the ice has been driven back by topography and dry katabatic winds, expose bare rock in one of the most alien-looking landscapes on Earth. Cold deserts receiving almost no precipitation. Scientists studying Mars come to the dry valleys because the landscape is the closest analogue on Earth to what Mars might look like if it has water ice near the surface. Below the ice in West Antarctica, the volcanic field raises questions about the relationship between geological activity and ice dynamics that are still being actively researched. The 91 volcanic peaks cluster along what appear to be rift structures, the ancient fault systems of the West Antarctic Rift, which has been extending and thinning the crust here for tens of millions of years. The same tectonic forces that have pulled West Antarctica into its low-lying, below-sea-level configuration have also provided the pathways for magma to reach the surface. All of this connects back to the lakes. The water in the subglacial lakes comes from somewhere. Some comes from pressure melting of the ice at the base of the sheet. Some comes from geothermal heat seeping up through the rock. And some of it, in West Antarctica, may come from volcanism, from the heat of magma making its way toward the surface and melting ice along the way. The lakes are the collecting points of all this water, the lowest basins in the subglacial landscape, the places where the water goes when it has nowhere else to go. Now let me say something about the scale of the subglacial water system that I may not have conveyed fully. When scientists say that water moves between Antarctic subglacial lakes through rivers and swamps, they mean this in a fully hydrological sense. There are channels, not the broad open channels of surface rivers, but channels nonetheless, carved over time by water flowing at the base of the ice. There are areas where the basal interface between ice and rock is a diffuse zone of saturated sediment, the subglacial equivalent of a wetland, where water is present, but not channelized, moving slowly through gaps between sediment grains. The satellite evidence for this system is elegant. When a subglacial lake fills, when more water arrives at it than drains away, the ice above it rises. Not by much, tens of centimeters over an area of tens of kilometers, but satellite altimeters, measuring the precise height of the ice surface to within a few centimeters, can detect this. And then, when the lake drains, the ice drops, and another lake kilometers away rises. The system breathes. Slowly, invisibly, under 4 kilometers of ice, the Antarctic watershed moves. The second comment ritual, placed here as gently as it will arrive, if you're still with me at this point in the night. And I know that many of you have already drifted off, which is exactly right. I'd like to ask you something. What is the most remote place you have ever been? Not necessarily the coldest, not the most extreme, but the place where you felt most clearly at the edge of what the ordinary world reaches. Tell me below. I'll read them tomorrow morning. Someone listening right now has an answer that will stay with me. The Denman Trench is worth a dedicated moment, because it is genuinely the most extreme topographic feature most people have never heard of. It is a subglacial canyon in East Antarctica, a depression in the bedrock more than 3,500 meters below sea level. The Mariana Trench, the deepest point in the ocean, is about 11,000 meters below sea level, so the Denman Trench is not in that class in absolute depth. But the Mariana Trench is under the ocean. It is covered by water, which is the expected material at those depths. The Denman Trench is covered by ice. It is the deepest land surface, the deepest rock surface on Earth. And it is filled with ice rather than water, because the canyon opens upward to the ice sheet rather than to the ocean. If the ice were removed, the Denman Trench would be a sea inlet, a fjord with a depth rivaling anything in Scandinavia and a length that would make it one of the major geographical features of the continent. The Denman Trench was not surveyed until relatively recently. The data that established it as the deepest land point on Earth came from a 2019 study using improved radar survey data and gravity measurements from satellite. Before that study, the previous record holder for deepest continental point was the Byrd Subglacial Basin, also in Antarctica. The two deepest land points on Earth are both in Antarctica, both filled with ice, both invisible, both surveyed without anyone seeing them. Antarctica holds the record for the most extreme hidden geography on the planet. Wave 4, the volcanoes, has a sensory detail worth sitting with. Mount Erebus, the southernmost active volcano, has a lava lake at its summit that has been continuously active since at least the 1970s, when systematic monitoring began, and probably for much longer. The lava lake is unusual. It is not the normal lava lake of a hotspot volcano, but a convecting body of an orthoclase phonolite, a type of lava found at very few places on Earth, churning slowly in a crater at the summit of a 3,700-meter mountain above the Ross Ice Shelf. From the summit of Erebus, on a clear day, you can see for hundreds of kilometers across the ice. The lava lake steams and moves. The ice below it is still. The contrast between the fire above and the frozen world below is, by all accounts, one of the most arresting sights in Antarctica. There is geothermal heat seeping up through the floor of the continent beneath you. You, reading this now, wherever in the world you are, at a rate that is too low to feel and too consistent to ignore. Everywhere, the mantle is slightly warmer than the surface, and heat flows upward. In Antarctica, this geothermal heat matters in a way it doesn't matter on most continents, because it is one of the sources that keeps basal water liquid. The heat that keeps Lake Vostok from freezing completely is, in part, the same heat that keeps the interior of the Earth from cooling, the residual heat of planetary formation, supplemented by the heat of radioactive decay deep in the mantle, seeping upward through billions of tons of rock at a rate of milliwatts per square meter. A candle gives off about a watt of heat. The geothermal heat flux under Antarctica is roughly equivalent to one candle every 3 square meters. Over the area of the ice sheet, it adds up to something significant. Over millions of years, it shapes the landscape. There is something that focuses the mind about Erebus, a smoking volcano above an ice sheet. Fire below and ice above, and, somewhere between them, the water that connects the two. The image concentrates what this whole night is about: pressure, heat, cold, and the surprising liquidity that results from their combination. Because there is water down there, a great deal of it, and that is where tonight finally goes quiet, into the lakes that have been sealed in the dark since before our species existed. Go down slowly now. Imagine standing on the East Antarctic Plateau. You are on the ice surface, at roughly 4,000 meters above sea level, high enough that the air is noticeably thinner than you're used to, high enough that the sky above you is a slightly deeper blue than you've seen before. The temperature is something your body would find difficult to process without extensive clothing. Even in summer, the plateau averages around -30 Celsius, and in winter, it falls to temperatures that would kill an unprotected person in minutes. The wind is variable, sometimes calm, sometimes the katabatic gale that pours off the plateau toward the coast at 70 kilometers an hour. The ice under your boots is flat. It looks flat to the horizon in every direction. There is no visible feature, no ridge, no dip, no sign of anything under the surface. And yet, if you were holding a good survey map and knew how to read it, you would know that directly below you, between 1 and 4 kilometers below you, depending on exactly where you were standing, there is liquid water. Hundreds of subglacial lakes have now been identified beneath the Antarctic ice sheet. The number varies in different surveys as the definition of what counts as a lake shifts, but the figure currently in wide use is above 400. 400 lakes, mapped from the air, detected by the way they appear in radar surveys, the flat, mirror-smooth reflection that liquid water produces, distinct from the rougher, less regular reflection from ice over rock. From an aircraft flying ice-penetrating radar, the signature of a subglacial lake is unmistakable, a bright, flat return from a surface that water alone produces at this scale. That is tonight's fourth whisper loop. Paid. 400 lakes beneath the ice. And not just lakes, a system. A connected system. Here is the premium framing for this part of the night. Radar and satellites have now located those hundreds of lakes under the ice, and water moves between them through a hidden network of rivers, streams, and subglacial swamps. There is a plumbing system down there, a watershed with its own slow hydrology, operating under kilometers of ice in the dark. The water moves because the ice above it moves. The Antarctic ice sheets are not stationary. They flow, slowly, toward the coasts, driven by the weight of the ice above and the slope of the ice surface. As the ice flows, it can empty one subglacial lake. The outflow event lifts the ice surface enough that satellites detect it. A subtle rise of tens of centimeters spread across kilometers, and fill another. Satellites monitoring the shape of the ice surface have documented these fill and drain events, watching the ice surface rise over one lake and fall over another, and inferring the flow of water between them. It is, in miniature, the hydrology of a river system, but sealed under 4 kilometers of ice, invisible to anything but the most patient remote sensing. The largest and most famous of the subglacial lakes is Lake Vostok. Vostok Station is the Russian research station on the East Antarctic Plateau, the station where the record low temperature of -89.2 degrees Celsius was recorded. It is one of the most remote inhabited places on Earth, accessible only by air or, in summer, by the long tractor traverse from the coast. It sits at roughly 3,488 meters elevation, and directly beneath it, under about 4 kilometers of ice, is Lake Vostok, a lake roughly 250 kilometers long and 50 kilometers wide, comparable in scale to Lake Ontario in North America. Lake Vostok has been sealed under the ice for an estimated 15 to 25 million years. The water in it is ancient. It accumulated over millions of years of melting at the base of the ice above, where geothermal heat from the rock below keeps the water at its pressure-adjusted melting point. The pressure at that depth is enormous, more than 300 times atmospheric, and under that pressure, the melting point of ice is depressed, so the water remains liquid even though its temperature is below the normal freezing point of water. The lake has its own internal circulation. It has its own weather, not weather in the atmospheric sense, but circulation patterns driven by the geothermal heat coming from below and the cold ice descending from above. In some models it has convection cells, like a very slow-moving ocean. Russian scientists at Vostok Station spent decades drilling toward the lake. The project began in the 1970s and continued for 4 decades, a drilling operation of extraordinary patience and technical difficulty, working in some of the most extreme conditions in the world, drilling through ice that had to be continuously lubricated to prevent the borehole from closing. They drilled to within 100 meters of the lake's surface, then stopped, concerned about contamination. The fear that drilling fluids carrying surface microorganisms might reach the ancient, sealed water and corrupt the biological record they hoped to find there. In 2012, after years of preparation, they broke through. The drill reached the lake, and lake water, long under pressure, rose into the borehole. The scientists immediately refroze the borehole, sealing it again. They had touched the lake, just barely, and the samples they retrieved from the refrozen water were eagerly analyzed. The results were cautious. Some genetic material was detected, but the interpretation was complicated by questions about contamination. The definitive biological survey of Lake Vostok is still pending. The experience of standing on the ice at Vostok, knowing what is underneath you, is one that the scientists who have been there describe with a particular quality of attention. You are standing on a surface under which a lake has been sealed for longer than the Gamburtsev Mountains have been sealed. The lake has never seen the sky. Its water has never evaporated. No sunlight has touched it in perhaps 15 million years. And yet it is liquid. It moves. It circulates. And it may be alive. The sealed water that is most certainly alive is not Vostok. Blood Falls is a slow stain on the face of Taylor Glacier in the McMurdo Dry Valleys, a region of East Antarctica where the ice has been sublimated away by the dry cold and the bare rock is exposed. The falls are named for their colour, iron red. Brine seeps out from within the glacier at this point, staining the ice as it escapes, leaving a permanent rust-coloured streak on the white. The colour comes from iron-rich brine that has been sealed within the glacier for more than 1 million years, sealed beneath the ice, in contact with iron-rich subglacial sediments, long enough for the iron to oxidize and the brine to become extraordinarily concentrated. And in the brine, there are microorganisms, a community of at least 17 different types of bacteria, living in a salt solution 3 times saltier than seawater, in complete darkness, at temperatures below zero, sustained by the chemical energy of iron oxidation rather than sunlight. They have been there for a very long time. The sealed world is leaking, and what leaks is red and alive, and carries inside it a record of what it was like to be life in the dark. Blood Falls is the image tonight's segment rests on. A sealed world leaking, the red iron seeping out like a slow announcement that the darkness is not empty. Now, Lake Mercer. In the austral summer of 2018 to 2019, a team from the SALSA project, the Subglacial Antarctic Lakes Scientific Access Project, drilled through a kilometre of ice at a site about 600 kilometres from the open ocean in West Antarctica. The drill was a hot water drill, a device that melts its way through ice by pumping pressurized hot water through a nozzle, creating a narrow borehole. The drilling was conducted under strict protocols to prevent contamination. The equipment was sterilized to a standard approaching a hospital clean room. The water used for drilling was filtered and treated. The team was trying to access subglacial Lake Mercer without contaminating it. They broke through on December 26, 2018. Water rose up the borehole. They lowered instruments. The water in Lake Mercer was not sterile. The team found bacterial cells, alive, metabolizing. They found genetic material representing a diverse microbial community. And then they found something that surprised them more than the bacteria, the carcasses of tardigrades and small crustaceans. Tardigrades are among the hardiest animals known. They can survive extreme desiccation, extreme cold, extreme pressure, even exposure to the vacuum of space. Their presence, even as carcasses, in a subglacial lake under a kilometre of ice, hundreds of kilometres from the sea, implies that the animals had been there, living, at some point. The crustacean carcasses implied the same. These are not microorganisms. These are animals. Animals that once lived in a sealed lake under a kilometre of ice, far from any ocean, in the permanent dark. Where did they come from? The honest answer is, we don't know precisely. The leading hypothesis is that they washed in from the ocean through an ancient subglacial drainage route, carried as carcasses or as dormant organisms through the hidden plumbing system and deposited in the lake when it was connected to other waters. They may have been there for thousands of years. They may have been active there, living and dying, before the connection to the outside water system closed and the lake became fully sealed. The lake is now sealed again. The borehole was allowed to refreeze. Lake Mercer is back under its kilometre of ice, its microbial community metabolizing slowly in the dark, its mysteries largely unexamined. The reason space agencies fund Antarctic subglacial lake research is specific and worth stating plainly. If you are looking for life on Europa, Jupiter's moon, which has a global ocean beneath its ice shell, completely sealed from the surface, or on Enceladus, Saturn's moon, which has a subsurface ocean and jets of water vapor erupting from its south polar region, the best model you have on Earth for a sealed ice-covered lake with potential life is a subglacial Antarctic lake. The Antarctic lakes are the rehearsal space for astrobiology. The techniques developed to access them without contamination, the instruments developed to analyze their water, the frameworks developed to interpret what is found. All of these will be used, eventually, on ocean worlds around other planets. The sealed lakes of Antarctica are, in a real sense, the reason we believe life might exist in the outer solar system. Not because the lakes prove it, but because they show what life can do in the dark, under the ice, far from the sun, sealed and patient and alive. The experience of standing above a subglacial lake, knowing that the ice under your boots is covering something liquid, something ancient, something biologically active, is one that Antarctic scientists describe with a particular tone. Not awe exactly, though that is present. More like standing in a cathedral, a sense of scale and enclosure, of being inside something with its own rules. The weight of the ice at 4 kilometers depth produces a pressure of roughly 400 atmospheres. At that pressure, the physical properties of water are different from what you encounter at the surface. The melting point is depressed. Ice will melt at temperatures below 0 Celsius under that pressure. This is why there is liquid water at the base of the East Antarctic ice sheet. Not because the temperature is warm, but because the pressure is enormous. The water exists in a regime that requires a physicist to explain in conditions that no surface organism could tolerate. Blood Falls is perhaps the clearest demonstration of where the old assumptions about life broke down. The bacteria living in the brine are not merely tolerating the hostile conditions, hypersaline, oxygen poor, cold, they are adapted to them, using the chemical energy available in the iron-rich environment rather than sunlight. They have had a very long time to adapt. The discovery of life at Blood Falls changed the assumptions. The drilling of Lake Mercer and the finding of tardigrade carcasses changed them again. Each time, the threshold for where life is found has been pushed to a more extreme position. Each time, what was previously thought impossible has turned out to be merely difficult. The reason space agencies fund Antarctic subglacial lake research is specific and worth stating plainly. Europa's ocean is estimated to be roughly twice the volume of all the water on Earth's surface, sealed under an ice shell of significant thickness, in contact with silicate rock, with tidal forces from Jupiter generating heat. The parallel to Antarctic subglacial lakes, ice above, rock below, liquid water between, energy from geothermal or tidal sources, is not metaphorical. It is precise. The physics are analogous. The biology, if it exists on Europa, may be analogous to what survives in Antarctic sealed lakes. The sealed lakes of Antarctica are the rehearsal space for astrobiology. Everything here is a rehearsal for something further away. Lake Vostok has its own internal circulation. It has its own slow weather, circulation patterns driven by the geothermal heat coming from below and the cold ice descending from above. In some models, it has convection cells, like a very slow-moving ocean. Russian scientists at Vostok Station spent decades drilling toward the lake. The project began in the 1970s and continued for 4 decades, a drilling operation of extraordinary patience and technical difficulty, working in conditions that make everything twice as hard. They drilled to within 100 meters of the lake's surface, then stopped, concerned about contamination. In 2012, they broke through. The drill reached the lake, and lake water, long under pressure, rose into the borehole. The scientists immediately refroze the borehole, sealing it again. They had touched the lake, just barely. When the Salsa team drilled into Lake Mercer in December 2018, the instruments they lowered into the water detected more than just bacteria. The water contained sediment, particles that had been in motion, transported by currents within the lake. The sediment showed traces of different origin points, implying that the lake was connected, at some point in its history, to other water bodies through which sediment could travel. The crustacean carcasses found in the Mercer water are from animals that required, at some point, access to nutrients that a fully sealed lake would not provide in sufficient quantity to maintain a population. This implies that the lake was, at some point, less sealed than it currently is, that animals colonized it during a period of connectivity and then were trapped when the seal reclosed. The honest answer is that we don't know if they survived. The lake is sealed again, the borehole refroze, the instruments are gone. What is happening in Lake Mercer right now is not known and cannot be known without another drilling project. That not knowing is the condition of Antarctic science. It is a science of inference and patience and return visits. Scientists go, they measure, they leave, they come back, years or decades later, and measure again. The comparison between the measurements tells them what changed. Between the visits, the continent does what it does, in the dark, under the ice, without observation. The phrase, sealed for millions of years, is one that gets used a lot in discussions of Antarctic subglacial lakes, and it is worth thinking about what it actually means. The last time the water in Lake Vostok was connected to the global ocean, the last time a molecule of Vostok water could have followed a pathway to the surface, was perhaps 15 million years ago. 15 million years ago, the hominid lineage had not yet diverged from the other great apes. The genus Homo did not exist. The species that would become modern humans were tens of millions of years in the future. The water that is in Lake Vostok was sealed before any of our ancestors were recognizably our ancestors, before the ice ages in their modern pattern had begun, before the Alps had reached their current height, before the Himalayas were as tall as they are now. And it has been there since, in the dark, under the pressure, moving slowly, possibly living. The light safety valve for this segment, placed here as promised. The biological findings from Antarctic subglacial lakes are preliminary and contested. The genetic material detected in the refrozen Vostok water has been challenged on contamination grounds. The Lake Mercer results are more robust but not yet fully published in final form. The picture is tantalizing and genuinely exciting, and it is also incomplete. This is what science looks like when it is working in the most extreme available environment with the best available tools. Findings are provisional, interpretations are debated, and the honest answer to many questions is, we don't know yet. That is not a disappointment. That is the current location of the frontier, one light safety valve placed here. The biological findings from all these lakes are preliminary. Lake Vostok has not been definitively sampled. Lake Mercer's biological record is not yet fully characterized. Blood Falls is extraordinary, but it is one location. The picture is tantalizing and genuinely exciting, and it is also incomplete. Science is doing what science does, approaching the sealed places carefully, with clean instruments and honest uncertainty. That is not a limitation. That is what it looks like when the best available method is being applied to the most extreme available environment. It is time to come back up through 4 kilometers of ice and say plainly what all of this means, and what the ice itself has been keeping for us the whole time. Come back up slowly. The deepest ice on Earth has trapped inside it something that no other archive holds. Every snowflake that falls on the Antarctic plateau is a sample of the atmosphere at the moment it fell. The snow compresses, layer by layer, into ice, and the ice traps tiny air bubbles, and those bubbles contain the actual air of their era. Actual ancient atmosphere, held inside solid ice, retrievable by drilling. Ice cores are the most direct record of past climate that Earth provides. Every year, a new layer is laid down, and that layer contains the atmosphere of that year's air. Ice cores from Antarctica have provided a continuous record of atmospheric composition and temperature going back 800,000 years. 800,000 years. That is 16 full glacial cycles, 16 times that the world has grown cold and then warm again, and each cycle is recorded in the ice. The concentration of carbon dioxide in the atmosphere, the temperature at the time the layer was laid down, the presence of volcanic dust from eruptions, the presence of cosmic dust from space, all of it is in there, waiting to be read by drilling down through the layers. The oldest ice yet recovered from a core is from a site called Little Dome Sea in East Antarctica, where a project called Beyond Epoca has reached ice dating to approximately 1.2 million years ago. The project's goal is eventually to reach ice that is around 1.5 million years old, ice from a period before the current pattern of glacial cycles established itself, from a time when the rhythm of the ice ages was different from what we know today. Think about what that means. Snow that fell before the pyramids were built is still in place, in an Antarctic ice core, still holding a breath of the atmosphere of its moment. The bubble of air inside the ice is the same air that was blowing across the Antarctic plateau when that snowflake formed. Nobody has breathed it. Nothing has processed it. It is the oldest preserved sample of Earth's atmosphere, and it is still there, under the weight of everything that fell on top of it. That is pure sleep material. Snow that fell before anything you know of the human world was still in place, patient in the dark, waiting for someone to drill carefully enough to reach it. Let me give you the resolution to the master loop, now, because you've earned it. What lies beneath Antarctica's ice? Here is the honest, complete answer. There is a mountain range the size of the European Alps, the Gambutseff subglacial mountains, whose peaks no human eye has ever seen, preserved by 34 million years of ice from the erosion that would otherwise have worn them flat. There is the deepest point of land on Earth, the Denman Trench, more than 3,500 meters below sea level, a canyon filled with ice, invisible to anyone who has not read the subglacial map. There are 91 volcanoes identified beneath the West Antarctic ice sheet, with heat leaking upward from below, keeping basal water liquid in the dark. There are 400 lakes, connected by rivers and swamps that no river has ever seen, a hidden watershed operating under kilometers of ice. There is the fossil ground of a temperate rainforest, roots, pollen, individual plant cells, preserved in sediment at the bottom of the Amundsen Sea, unchanged for 90 million years. And in the sealed lakes there is life, microorganisms at minimum, and the evidence that larger animals have lived in the darkness as well. None of this was built, none of it was hidden deliberately. There is no lost civilization here. There is something rarer. The ice is not a blanket over Antarctica. It is a lid on a jar, and everything in the jar is still exactly where it was the day it closed. That is the resolution. The continent was buried alive, not violently, not traumatically, but conclusively, by a climate event 34 million years ago, and what was buried has been kept. The forests stopped growing and were kept. The mountains stopped eroding and were kept. The water pooled in the hollows and was kept. The microorganisms found their energy sources and lived, in the dark, and kept living. The continent did not disappear under the ice, it was preserved by it. Here is where I want to give the honest modern thread its brief moment, placed here and nowhere else. Because this is a sleep video, and the register must hold. The lid is thinning in places. The West Antarctic ice sheet is losing mass. Satellite measurements over the last several decades have documented this with increasing precision. Glaciers at the edges of the continent are accelerating. The Thwaites Glacier, sometimes called the Doomsday Glacier in dramatic press coverage, a name the scientists themselves do not use, is losing ice faster than any point in the observational record. What melts stops being sealed. What melts is exposed, and then processed by the ocean and the atmosphere, and becomes something different from what it was. The Gambutsev Mountains will remain sealed for the foreseeable future. The deep interior of East Antarctica is changing more slowly. But the edges are moving, and the lakes in West Antarctica are part of a system that is connected, under the ice, to what is happening at those edges. I mention this once, calmly, and I leave it here. You can do what you need to do with it in the morning. It is not what tonight is about. Tonight is about what the ice has been keeping. And the most patient act of exploration in the history of human science, the act of listening to a continent from the air for 70 years, drawing a map of a place no one has looked at, building bed map from echoes and gravity measurements and satellite readings, until the map is better than anything a human eye could have produced anyway, deserves to be named for what it is. People listened to a continent for 70 years and drew a map of a place no one has ever seen. That is the most patient form of attention one species has ever paid to another part of the world it lives on. One calm callback, because this is a shelf that connects. The tradition in very old texts, including the Enochic literature we visited on earlier nights, of a sealed place at the ends of the earth, beyond the reach of the living world, where something is kept that cannot be opened. Antarctica is real. The seal is geological, not supernatural. But the intuition that the southern end of the world hides something sealed, something vast, something that has been there since before the human world began, is not wrong. It is, in its way, the most accurate ancient geographical intuition. There is a sealed place at the ends of the earth. The seal is 34 million years old, and what is sealed inside it is stranger and more beautiful than any text imagined. The Ice Core Archive deserves more space, because it is one of the greatest scientific instruments ever built, made not by human hands but by time itself. A well-drilled ice core from the East Antarctic Plateau contains actual samples of ancient air. The bubbles in the ice are actual molecules that were floating in the sky above Antarctica at the moment the snow compacted enough to trap them. Scientists can extract those bubbles, measure the composition of the air inside them, and determine the concentration of greenhouse gases at the time the layer was deposited. The result is a curve, the Vostok climate record, extended by subsequent drill sites, that shows, with fidelity no other archive provides, how Earth's climate has oscillated between glacial and interglacial periods over the last 800,000 years. 8 complete glacial cycles. The current concentration of atmospheric CO2 is higher than at any point in the last 800,000 years. And this is not a model or an inference. It is a measurement of actual ancient air. The fact is, in the ice, in a bubble, waiting on a shelf in a cold storage room at a research institute somewhere in the world, there is volcanic dust in the ice as well. Major eruptions leave a sulfate signature that can be matched to historical records of volcanic activity. Tambora in 1815, Krakatoa in 1883, the Great Toba eruption 74,000 years ago, all left traces in the Antarctic ice. There is cosmic dust too, micrometeorites, captured by Earth's atmosphere, settling and being preserved. The ice core is a record of major volcanic events, atmospheric composition, and cosmic infall, a library that accumulated for 800,000 years before anyone thought to read it. What remains unknown about Antarctica is, in some respects, more humbling than what is known. Most of the bedrock has never been directly sampled. The Kilometres mountains have been mapped by radar, but no geologist has ever picked up a piece of Kilometres rock. The Denman Trench has been located and measured by remote sensing, but no instrument has ever been lowered into it. Most of the 400 subglacial lakes have never been touched. This is the current state of an enormous project, carried by a small community of researchers working in the most extreme environment accessible to humans, using instruments that will be superseded by instruments that don't exist yet. The pace of discovery in Antarctic science over the last 20 years has been remarkable. The pace over the next 20 will likely be remarkable in different ways. The return to the surface involves crossing back through the layers of what you've seen tonight, and it's worth doing that slowly. At 4 kilometers deep, the fossil forest floor, roots, cells, pollen from 90 million years ago, perfectly preserved in cold mud at the bottom of the Amundsen Sea. At 3 kilometers deep, the base of the East Antarctic ice sheet, where ancient air is trapped in bubbles, still holding the chemistry of its moment. At 2 kilometers, the Kilometres mountains, their peaks sharp and their valleys unchanged, the colours still in the stone, nobody having ever looked at them. At 1 kilometer, the subglacial lakes, 400 of them, their water moving slowly in the dark, their microbial communities metabolizing the chemicals in the rock. At a few hundred meters, the base of the ice where volcanic heat seeps up from below and the meltwater flows toward the lakes. Everything in this story is connected to everything else. The rainforest floor is down there because the ice covered it. The Kilometres mountains are sharp because the ice protected them. The lakes are liquid because the ice above them provides the pressure. The ice cores hold their ancient air because the ice has been accumulating, layer by layer, for 800,000 years. The ice is not the enemy of what's underneath it. The ice is what made the underneath worth studying. And the scientists who have dedicated their careers to this, to listening to a continent, to drilling cores and flying radar surveys, and interpreting satellite altimetry, and designing clean room drills to enter sealed lakes, are doing something that requires, at its core, an act of scientific faith. The belief that the patience required will eventually be rewarded by understanding that the data you collect now will be interpreted by someone who hasn't been born yet. Antarctic science is multi-generational. The IGY surveys of the 1950s are still being built on. The ice cores drilled in the 1980s are still being reanalyzed with new techniques. The Kilometres data from the AGAP project is still yielding new papers. The information does not expire. The ice keeps it. The honest open questions deserve naming clearly. Most of Antarctica's bedrock has never been directly sampled. BedMap is a map of inferences, not a map of observations. The Kilometres mountains have been mapped by radar, but no geologist has ever stood on their slopes or picked up a piece of their rock. The Denman Trench has never had an instrument lowered into it. The subglacial drainage system, the rivers and swamps and connections between the lakes, is known in outline but not in detail. The biological record of the sealed lakes is barely begun. These are not failures. They are the current state of an ongoing project, being carried forward by a community of researchers doing difficult work in genuinely extreme conditions, with instruments that did not exist a generation ago and will be superseded by instruments that don't exist yet. And what is true either way, what is true regardless of what future drilling and survey finds, is this. People listened to a continent for 70 years and drew a map of a place no one has looked at. They sent sound into the ice and listened to the echo. They flew aircraft back and forth over the emptiest terrain on Earth and measured the radar returns. They read the shape of the ice surface from orbit and inferred the shape of the rock below. And from all of that listening and inferring and measuring, they built a picture of a place that is more detailed than any traveller's account could have produced, more accurate than any human eye at the surface could have yielded, because the instruments are more patient and more precise than any human observer. It is the most patient act of exploration in human history, the exploration of a continent by remote sensing over 7 decades without anyone ever seeing the place being explored. The open questions are not small. Most of Antarctica's bedrock has never been directly sampled. BedMap is a map of inferences, not observations. Only a handful of subglacial lakes have been touched. The Gamburtsev Mountains have never had a geologist standing on their slopes. The Denman Trench has never been seen. The biological record of the sealed lakes is barely begun. These are not failures. They are the shape of an enormous ongoing project, carried by a scientific community that is doing genuinely difficult work in genuinely extreme conditions. But they mean that what we know about what lies beneath the ice is already astonishing, and also, demonstrably, incomplete. What we find when we get there will be what was always there. The mountains will be mountains. The canyons will be canyons. The lakes will be lakes. The fossil forest floor will be the fossil forest floor. Nothing has been hiding. Everything has been waiting. You do something like this yourself, not with ice, not with 4 kilometers of accumulated time, but everything you are right now is layered. The person you were at 6, at 14, at 23, at every age you've been, all of it is still down there, sealed under everything that settled afterward. You haven't lost any of it. You haven't deleted any of it. It is covered, the way the Antarctic forest is covered, pressed into the sediment of who you've become. And every so often, not often, and not predictably, some ordinary moment passes through you like a scanner. The smell of something, the light at a certain angle, a phrase in a book, a song on the radio at the exact wrong or right moment. And there it is, roots, cells, a whole living season you thought was gone, preserved perfectly under everything that settled on top of it. Not lost, kept. Antarctica is the planet doing what memory does. The ice is not destruction, the ice is conservation. The things that were sealed are not diminished by being sealed. They are protected. The mountains under the ice are sharper than they would be if they had spent 34 million years in the open air. The fossil forest floor is more detailed than any forest floor exposed to the surface has any right to be. The sealed lakes hold their chemistry unchanged. The ice preserved them by covering them. It is the most counterintuitive truth in geology. Being buried is sometimes better than being exposed. You are here, at this hour. In whatever place in the world you are at this hour, the layers of who you are all there, stacked beneath the surface of right now, and they're not going anywhere. They are, in the most literal geological sense, a record, a core that could be drilled if the instrument were fine enough, if the reading were careful enough. The instrument is memory. The reading takes a lifetime. None of this is to say that what is sealed should stay sealed forever. The scientists working on Antarctica are trying, carefully and respectfully, to open the right places in the right order with the right instruments. The goal is not to leave the sealed world sealed, it is to understand it, which requires, eventually, touching it. The same is true of what is sealed in you. The things buried in memory are not meant to stay buried permanently. They are there to be found, when the time and the instrument are right. But that is a project for the morning. Right now, the ice holds everything where it is. The mountains are in their places. The lakes are in their places. The fossil forest floor is in its place. The sealed air in the bubbles of the ice cores is holding its breath. Before the lullaby, a small, entirely optional moment. If tonight was the kind of night you come here for, the slow, patient, evidence-rich ones, a quiet tap-on like helps other quiet people find their way here, and I'd like to hear from you. Where in the world are you tonight? And what is down there in the layers of your life that you haven't thought about in a long time? Leave it below. I read them in the mornings, and they're the best part of the job. If you want to keep coming on nights like this one, the subscribe button will make sure you don't miss them. A membership, if that's something you want, is there. Completely optional. Keeping the ice company tonight is already more than enough. Now, somewhere in Germany, in a cold room in a laboratory at the Alfred Wegener Institute in Bremerhaven, there is a tube of grey mud on a shelf under a label. The tube is about a metre long. Most of it is grey. And near one end, if you look carefully along it, the way you look along a core when it comes up from the sea, there is one band that is a different colour. The core came up in February 2017, in the grey light of the Amundsen Sea. The ship held position while the drill worked 1,000 metres below. The core came up on deck. Someone looked along it. Someone said, "That's odd." And 90 million years of forest floor, 90 million years of roots and pollen, and the cells of plants that grew in the dark through months of polar night, 90 million years of it, lying quietly in the grey, announced itself by being slightly the wrong shade. It is still there, in the cold room, on the shelf. If you could unroll the whole of geological time alongside it, all 4.5 billion years, the band of wrong-coloured sediment would be an almost invisible stripe near one end. And 4 kilometres below where the ship floated, at the bottom of the world, the mountains no one has seen are exactly where they were tonight. The Denman Trench is exactly where it was. The sealed lakes are exactly where they were, their water moving in the dark in its slow circulations, their microorganisms metabolizing the chemicals in the rock below them, patient in the way that only the very old can be patient. The forest has waited 90 million years. It can wait until morning. The mountains can wait until morning. The lakes can wait until morning. The sealed and the preserved are not the same as the lost. This is worth saying clearly, because it is easy to slide from one to the other. The Antarctic forest is not lost. It is sealed. The Gamburtsev Mountains are not lost. They are sealed. The ancient air in the ice core bubbles is not lost. It is sealed. Sealed means it is still there, in the exact condition it was in when the lid closed, waiting for the right instrument and the right moment. There is a concept in geology called a Lagerstätte, a place where exceptional preservation conditions have produced an extraordinary fossil record. The most famous are places like the Burgess Shale, where soft-bodied creatures from 500 million years ago are preserved in such detail that individual organs are visible. Lagerstätten exist because something, rapid burial, unusual chemistry, specific physical conditions, prevented the normal decay. Antarctica is a Lagerstätte for a whole continent. The ice created the conditions for exceptional preservation, cold, dry, sealed from the atmosphere, protected from erosion. Everything that was there when the lid closed has been kept with extraordinary fidelity. You are, in some respects, your own Lagerstätte. The conditions of your life at particular moments created particular deposits, experiences, relationships, ways of thinking, that were then covered by subsequent events. What was there when the layers settled is still there. It waits in the cold and the dark of long-term memory for the right kind of attention. Clean instruments help. Genuine attention helps. Not forcing it open, waiting for the right moment and the right conditions, then listening carefully to what comes up. The layer is still there. The colour is still wrong, in the best possible way. Antarctica is the planet doing what memory does. Not the dramatic kind, not the vivid, burning recall of something that changed your life. The other kind, the kind that keeps things in their place without drawing attention to itself, the kind that doesn't announce itself until the right instrument arrives, the kind that holds for 90 million years without any effort, because holding is simply what it does. You do this with the people you've been, the 7-year-old who was afraid of a particular sound, the 14-year-old who discovered a particular book and felt something shift, the 20-something who made a decision that still has consequences. None of those versions of you are gone. They are sealed under the successive layers of who you became afterward. They are as sharp as they ever were, sharper possibly, because the ice of time has prevented the erosion that might otherwise have softened them into vagueness. The scientists who study Antarctic ice cores do not go looking for drama. They go looking for precision. They want to know exactly what the atmosphere was like in 43,000 BC. They approach the material with instruments calibrated to parts per billion, and they read what is there with the maximum possible fidelity. They do not impose a story on the record. They read the story the record contains. You can do that with yourself. The approach is slower and less precise, and the instruments available are less sophisticated. But the method is the same. Approach carefully, with clean attention. Read what is there, rather than what you expect to find, and trust that the record is more complete than you remember. The continent was buried alive 34 million years ago. It did not resist. The ice came, the forests stopped growing, the mammals moved away or went extinct, the rivers stopped flowing, and the continent, sealed under its lid, simply kept being what it was. The mountains kept their shape, the fossil forest kept its cells, the water gathered in the hollows. And eventually, after 34 million years of waiting, a ship called the Polarstern held position in the Amundsen Sea, and a drill went down, and a tube of mud came up, and somebody looked along it and said, "That's odd, the right instrument, the right moment." 34 million years of patience, rewarded by a colour. There is one more thing worth saying at this hour, in this dark. The core in Bremerhaven is not alone on its shelf. Alongside it are cores from the same cruise, from different positions in the Amundsen Sea, from different depths in the sediment. They are all grey. Only the one has its band of wrong colour. But the fact that only one core has it does not mean the forest was small. It means the sampling was sparse. The forest was almost certainly vast. The wrong-coloured layer is one thread from a fabric that covered an entire continent, and the rest of the fabric is still down there, still in the mud, still waiting in the cold. The tube on the shelf in Bremerhaven is not the forest, it is a memory of the forest. And there is more memory than anyone has yet found. One final thing about the core in its cold room in Bremerhaven. The tube of grey mud, with its one band of wrong colour, sits on a shelf under a label. The label gives it a catalogue number and a location, the GPS coordinates of the spot in the Amundsen Sea where it was drilled, the depth of the water, the depth in the sediment at which the wrong-coloured layer occurs. The label contains, in compressed form, everything needed to find that spot again and drill another core, to retrieve more of the fossil forest, to extend the picture, to answer questions that the first core raised. Science is like this. The first discovery is not the discovery. The first discovery is the question. The core raised questions about the extent of the forest, about the species composition, about the climate conditions that sustained it, about the transition from forest to the conditions that allowed the ice to form. Those questions will drive research for decades. The core is not the end of the story, it is the opening line, which is what the whole of Antarctica is in a sense. The continent is an opening line. The mountains, the lakes, the fossil forest, the ancient ice, the volcanic heat seeping up from below, the life in the sealed dark. All of it is a question waiting for the right instrument and the right moment. And the instrument is getting better. The moment is getting closer. The ice is patient. The science is patient. And what is sealed in the dark of that continent, what has been sealed since before our species existed, waiting without knowing it was waiting, will be, eventually, read. The world can wait until morning. For now, you can rest.